Have you ever wondered why some classic engines keep running strong for decades, while many modern engines seem to break down after just a few thousand miles? It's a question that has puzzled truckers, mechanics, and enthusiasts alike for years. In an era of cutting-edge technology and constant innovation, you'd expect today's engines to outperform those old workhorses. Yet the reality often tells a different story. Take, for example, some trucks from the 1970s that have logged over 3 million miles on their original engines. Meanwhile, many modern trucks struggle to hit 500,000 before facing major breakdowns. What causes this huge gap in durability? Is it simply the result of wear and tear? Or is there something deeper behind the longevity of these classic machines? In this video, we're going to uncover the secrets behind why classic engines last so long, and why modern engines sometimes can't keep up. We'll dive into the design choices, materials, and technologies that have changed over the years, and how these changes impact engine lifespan. Whether you're a truck driver, a gearhead, or just curious about the mysteries under the hood, this video will shed light on a topic few truly understand. But this isn't just a technical explanation. It's a story of trade-offs, where advances in efficiency and emissions have come at a cost to durability. It's about how the pursuit of cleaner, more powerful engines sometimes leaves reliability on the sidelines. And it's about the lessons we can learn from the past as we move into the future of trucking. So, stay with us until the end, because the answers might surprise you and could change how you see both classic and modern engines forever. Also, don't forget to hit that like button and leave a comment below sharing your own experiences with old or new engines. Your insights might just help others understand this engine mystery better. Classic engines earned their legendary status for a simple reason. They were built to last. Unlike today's complex, computerized powerhouses, these engines relied on straightforward mechanical designs that prioritized durability over every other factor. This simplicity was one of the key reasons why many of these engines continue to run smoothly after hundreds of thousands, even millions, of miles. One of the biggest advantages of classic engines was their mechanical simplicity. With fewer electronic components, sensors, and control units, there were simply fewer parts to fail. This made repairs easier and less costly, especially in the field. A skilled mechanic, or even a knowledgeable trucker, could often diagnose and fix problems without needing expensive diagnostic tools. This independence made these engines more reliable, especially in remote areas where specialized services might not be readily available. Materials also played a crucial role in the longevity of classic engines. Back then, manufacturers used heavier and more robust metals designed to endure constant stress and high temperatures. Cast iron blocks and steel components were common, providing strength and resistance to wear. Although these materials made engines heavier and less efficient by today's standards, their durability ensured they could withstand years of hard use. Another important factor was the design philosophy behind these engines. Classic engines were built with a focus on longevity and repairability, rather than squeezing every last drop of power or fuel efficiency. This meant tolerances were often looser, and engines could tolerate dirt, poor maintenance, and harsh operating conditions without catastrophic failure. They were designed to keep running no matter what. Maintenance routines were simpler too, which helped extend engine life. Routine tasks like oil changes, filter replacements, and valve adjustments could be performed easily and frequently. This proactive maintenance culture was common among truck drivers and fleet operators, who understood that keeping the engine in good shape was essential for avoiding costly downtime. Take, for example, the legendary Cummins NTC series or the Detroit Diesel 60 series, engines that became synonymous with reliability and toughness. These power plants were proven workhorses that could be found hauling heavy loads across the toughest terrains in America for decades. Stories abound of these engines running strong well past 1 million miles, with some even reaching the incredible milestone of 3 million. In summary, classic engines owe their longevity to a combination of mechanical simplicity, durable materials, conservative design choices, and ease of maintenance. These factors combine to create machines that could withstand the test of time and harsh working conditions, a feat that many modern engines struggle to match. As we transition to our next chapter, we'll explore why modern engines, despite their technological advancements, often face challenges that threaten their durability and longevity. Let's dive into the world of today's engines and see what's changed. While classic engines were designed with simplicity and durability in mind, modern engines have taken a very different path. Advances in technology have brought incredible improvements in power, fuel efficiency, and emissions control. But these gains have come with trade-offs, particularly when it comes to reliability and longevity. One of the most significant changes in modern engines is the extensive use of electronic components and computer-controlled systems. Sensors monitor everything from fuel injection timing to exhaust emissions, and onboard computers constantly adjust engine parameters for optimal performance. While these systems help meet strict environmental regulations and improve efficiency, they also introduce complexity and potential failure points. A single faulty sensor or electronic control unit can lead to costly repairs or even leave a truck stranded. In addition to electronic complexity, modern engines often use lighter and thinner materials to reduce weight and improve fuel economy. While this contributes to better mileage and lower emissions, it can also reduce the engine's overall robustness. Components made from aluminum or thinner steel may not withstand harsh conditions as well as the heavy cast iron blocks and thick steel parts of classic engines. This can lead to increased wear, cracks, or even catastrophic failure over time. Furthermore, modern engines must comply with stringent environmental standards, including emissions limits set by agencies such as the EPA. To meet these requirements, manufacturers have added complex exhaust treatment systems like diesel particulate filters, DPF, and selective catalytic reduction, SCR units. These systems are essential for reducing pollution, but add extra components that can clog, malfunction, or require expensive maintenance. The increased back pressure and heat from these systems can also stress the engine. The focus on maximizing efficiency often means tighter manufacturing tolerances and less margin for error. Modern engines are engineered to run at higher pressures and temperatures, which can push components to their limits. While this improves performance, it can also increase the risk of premature wear or failure if maintenance is neglected, or if the engine operates under harsh conditions. Many truck drivers and mechanics report that modern engines often demand more frequent and specialized maintenance. Diagnostic tools are necessary to interpret complex error codes, and repairs frequently require expensive replacement parts or software updates. This dependence on technology can be frustrating and costly, especially for independent operators or those working in remote locations. Despite these challenges, modern engines do offer advantages in fuel economy, reduced emissions, and power output. However, durability and ease of repair often take a back seat to these priorities. This trade-off explains why many modern engines struggle to match the multi-million-mile lifespans achieved by some classic engines. Understanding these limitations helps explain the ongoing debate in the trucking community about the merits of old versus new engines. As we've seen, the very features that make modern engines impressive also introduce vulnerabilities that can shorten their lifespan. In the final chapter, we'll summarize these insights and discuss what truckers and enthusiasts can learn from both classic and modern engine designs. In the battle between classic and modern engines, durability often favors the past. Classic engines, with their mechanical simplicity, robust materials, and repair-friendly designs, have proven their ability to endure decades of tough use. Meanwhile, modern engines, while excelling in efficiency and emissions, often sacrifice long-term reliability due to their complexity and delicate components. Understanding these trade-offs helps truckers and enthusiasts make informed choices about the engines they trust. Now, we want to hear from you. Do you prefer the tried-and-true durability of classic engines or the high-tech advantages of modern ones? Share your thoughts below, and don't forget to like and subscribe.